Next, we're going to go ahead and talk about muscle fiber types and the different characteristics between each. So if we zoom out and take a look at the muscle as a whole, each muscle is going to have a different distribution of type 1 or type 2 muscle fibers. A motor unit is composed of muscle fibers that are all the same type. So a type 1 motor unit is only going to innervate type 1 muscle fibers. When activating a muscle, we're first going to recruit type 1 fibers. If more force is needed after that, then we'll move on to type 2A, and then we'll move on to type 2X. Next, we're going to talk about muscle fiber types, the motor units that supply them, and some motor unit recruitment patterns. So there's two types of motor units, and that would be a slow twitch and a fast twitch. Slow twitch motor units are going to develop force and relax really slowly. Fast twitch motor units are going to develop force and relax quickly, hence the name fast twitch and slow twitch. So slow twitch motor units have a high resistance to fatigue, which means that they fatigue very slowly. On the other hand, fast twitch motor units fatigue very quickly, and this is why you would need a lot of rest after an activity that involves a lot of fast twitch muscle fibers. So next we're going to talk specifically about type 1 muscle fibers and their characteristics. So when we think of type 1 muscle fibers, we should be thinking of endurance activities. So these activities are ones that involve oxygen. That's going to be the key point here. So in activities like marathon running or cross-country skiing, these fibers are going to be heavily involved. So again, if we think about what fuels endurance activity, it's the aerobic system. A lot of oxygen is present and the main source of ATP. So the motor neuron size for type 1 muscle fibers is small. So that means that it might only innervate a few fibers compared to type 2 muscle fibers, which might innervate 100 muscle fibers. The fiber diameter is going to be small and the color is going to be red. So just remember, oxygenated blood is red. We can think oxygen is present, so these muscles are going to be red. So remember, they're going to be a lot slower. So the nerve conduction velocity, the contraction speed, and the relaxation speed are all slow. So if we think of that twitch graph, that line is going to be more drug out rather than a quick spike. So in type 1 muscle fibers, the recruitment threshold is low. So when activating a muscle, we're going to first activate and recruit type 1 muscle fibers. Then if more force is needed, we're going to move on to type 2A and then type 2X. The power output and force production are going to be low. The anaerobic enzyme content is going to be low. And the sarcoplasmic reticulum complexity is also going to be low. However, these muscles are fatigue resistant and they have high endurance. So those kind of go hand in hand there. Their aerobic enzyme content is high. Their capillary density, myoglobin content are high, which myoglobin is what delivers oxygen to the muscle. So of course that's going to be high. And then the mitochondrial density is also high. Next, we're going to take a look at type 2A muscle fibers. So these fibers are intermediate. So they kind of have mixed characteristics between type 1 fibers and type 2X fibers. So these have a large motor neuron size, which means that a motor unit is going to innervate more fibers than it would for a type 1 muscle fiber. They're going to be white/red. Their nerve conduction velocity, their contraction speed, and relaxation speed are all going to be fast. So they kind of gear toward the anaerobic end of things. These next characteristics are all kind of fall in between type 1 muscle fibers and type 2X muscle fibers. So their recruitment threshold is intermediate. Their resistance to fatigue and their endurance level is intermediate. So not as resistant to fatigue as type 1, but more resistant to fatigue than type 2X. Their force production and power output are also going to be intermediate, fall in the middle somewhere. Their aerobic enzyme content is going to be intermediate as well. Their sarcoplasmic reticulum complexity, their capillary density, mitochondrial density, fiber diameter are all going to be intermediate as well. And then their anaerobic enzyme content is actually going to be high. So again, it's gearing toward the anaerobic metabolism side of things. Their myoglobin content is going to be low. So again, that's what delivers oxygen to the muscle. Moving on to type 2X muscle fibers. So this is essentially everything opposite of type 1 muscle fibers. So these muscle fibers are going to be heavily involved in power activities. So things like Olympic lifts or even like a quick 10-yard sprint. So their motor neuron size is going to be large. So again, it's going to innervate a lot of fibers. They have a large fiber diameter and their color is white because it's going to be lacking oxygen. Their nerve conduction velocity, contraction speed, and relaxation speed are all going to be fast. Their recruitment threshold is going to be high. So remember, it takes longer to recruit these fibers. Their power output, force production is going to be high. Again, we use these for power activities. Their anaerobic enzyme content and sarcoplasmic reticulum complexity are going to be high. Again, involved in anaerobic processes. They have low resistance to fatigue, so that means they fatigue quickly and they need a lot of rest for these activities. They have low endurance, low aerobic enzyme content. Their capillary density and myoglobin content are low, so again, not a lot of oxygen involved here, and their mitochondrial density is low. So let's see how these muscle fibers are involved in specific sports or activities. So in sports where we have low type 1 involvement, but high type 2 involvement. Again, this is going to be your power activities. So 100-meter sprint, Olympic weightlifting, a wide receiver running a route, a lineman quickly jumping off the line, basketball, baseball, volleyball, a quick 50-meter swim, things like this. That's all going to involve a majority of type 2 muscle fibers as opposed to type 1 muscle fibers. Next, we've got activities that are very high in both of these muscle fiber types. 800-meter run, soccer, lacrosse, and hockey, that's going to have a mixture of low intensity bouts and high intensity sprints. Boxing, wrestling, tennis as well. And then we have skiing and speed skating. So these are those intermediate sports that kind of involve both types of activities. And then we have our endurance sports. So these are going to have high type 1 involvement, low type 2 involvement. So marathon running, cross-country skiing, or distance cycling are all going to be activities that fit into this category. So muscular force can be varied in two ways. The first way is the frequency of activation of individual motor units. So again, when we were talking about that single twitch and then the summation of twitches, so that's increasing the frequency. And then the second way is the amount of motor units that are activated. So this is the recruitment portion. So the type of motor unit recruited is based on the activity. So for example, in a power clean exercise, most of the motor units that are recruited are going to be fast twitch because it's a high force, high power movement. Complete activation of available motor neurons is probably not going to be possible in untrained people. So how can athletes improve force production? Well, there's 3 different ways they can. First, they can incorporate heavier loads to optimize neural recruitment. Second is they can increase the cross-sectional area of muscles involved in that desired activity. And third is they can perform multi-muscle, multi-joint movements that can be done with explosive actions. That's going to optimize fast twitch muscle recruitment.